Derivatives of trigonometric functions. You should have this handout with these rules. I numbered them 1 through 8. The rules numbers 7 and 8 are not trigonometric functions, so we'll use those in a later section. We're going to do some exercises from page 140. Eventually, you'll need to memorize all of these rules for the derivatives of trigonometric functions, plus rules 7 and 8 on this list. On page 140, exercise 2, y equals 2 sine x minus tan x. The directions are to find the derivative of y with respect to x. So we just copy the 2, and the derivative of sine x is cosine x. The minus gets copied. The derivative of tan x is secant squared x. We're done. So we used the first rule, the derivative of sine x is cosine x. And we used the third rule, the derivative of tan x is secant squared x. Number six. Y equals 3x plus x times the tangent of x. The directions are to find the derivative of y with respect to x. The derivative of y with respect to x. The derivative of 3x is 3. Plus gets brought down. This blue and green is called a product. X times the tangent of x. The derivative of a product is always the first times the derivative of the second plus the second times the derivative of the first. So I'll repeat, the derivative of x tan x is the first times the derivative of the second plus the second times the derivative of the first. And this is the answer. So the blue and green, the derivative of blue times green is the first, which is x, times the derivative of tan x, which is secant squared x, plus the second is tan x, times the derivative of the first. The derivative of 1x is 1. So for exercise 6, dy dx equals 3 plus x secant squared x plus tan x. That's it. Number 10. Y equals cosine x, that's a numerator, over 1 plus sine x. That's a denominator. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. The derivative of y with respect to x is the denominator times the derivative of the numerator. I just used the second rule on that list of rules. the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So I'm going to repeat the words so I can remember where I left off. The denominator, which is green, times the derivative of the numerator minus the numerator times the derivative of the denominator. The derivative of 1 plus sine x is 0 plus cosine x. The derivative of 1 is 0 because 1 is a constant. The derivative of sine x is cosine x. All over the denominator squared. So there's the quotient rule. Denominator, derivative of numerator, minus numerator times the derivative of the denominator, all over the denominator squared. So we distribute negative sine x times 1 is negative sine x. Negative sine x times sine x is negative sine squared x. And over here, this is negative cosine x times cosine x. That's cosine squared x. All over 1 plus sine x, quantity squared. Well, there's a trig identity. There's a trig identity that everybody knows, that sine squared x plus cos squared x is 1. Everyone knows this. So therefore, negative sine squared x, negative cos squared x must be negative 1. So back over here, exercise 10. This right here, put yellow around it. All that yellow is negative 1. All over 1 plus sine x squared. Negative sine squared x, negative cos squared x equals negative 1. And the numerator, both terms are negative, so we can write that as negative 1 outside of sine x plus 1. The negative 1 that's in both terms factored out. The denominator is 1 plus sine x squared. That means 1 plus sine x times itself. So in simplest form, the answer to exercise 10 is negative 1 over 1 plus sine x. Because we are doing this. And that's it. That's number 10. Number 12. Y equals tan x over x. And it says at x equals pi over 4. When x is pi over 4, y is equal to the tangent of x, which is pi over 4, over x, which is pi over 4. And I need to know by heart that the tangent of pi over 4 is 1. 1 over pi over 4 is the same as 4 over pi. So in exercise 12, we're going to find the derivative of y with respect to x, which is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So if we, that's the derivative. If we find the derivative of y with respect to x when x is pi over 4, like it says in the directions in the question, that would be pi over 4 times secant squared pi over 4 minus the tangent of pi over 4 all over pi over 4 squared. I just took this derivative, which we got using the quotient rule, and replaced every x with pi over 4. So pi over 4 goes there, 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 and there. Pi over 4 is 45 degrees. Pi over 4 is 45 degrees. The cosine of 45 degrees is radical 2 over 2. That makes the secant is the reciprocal of cosine. Where it says secant pi over 4, we put 2 over radical 2. But it's secant pi over 4 squared. The tangent of pi over 4 is 1. Copying everything else. So pi over 4, when we square 2 over radical 2, we get 4 over 2. When we square pi over 4, we get pi squared over 16. Well, these 4's cancel right here where I'm pointing, so that's pi over 2 minus 1 over pi squared over 16. And we can multiply this numerator by 16 if we want to, as long as we multiply the denominator by 16. We can multiply the numerator by 16 because we're going to multiply the denominator by 16. 16 times pi over 2 is 8 pi. 16 times negative 1 is negative 16. And 16 times pi squared over 16 is just pi squared. This number right here is the derivative of y with respect to x when x is pi over 4. In other words, that number is the slope of the tangent line at x equals pi over 4. This number right here, 8 pi minus 16 over pi squared. So this exercise that we're doing, exercise 12, says find an equation of the line normal to y equals tan x over x at x equals pi over 4. The slope of the normal line at x equals pi over 4. Is going to be the negative reciprocal of the slope of the tangent line. This number is the slope of the tangent line. The slope of the normal line, we make the reciprocal. So that's just pi squared over 8 pi minus 16. But we negate that by putting a negative there. That number is the slope of the normal line. The equation of a line is y minus a number equals the slope, parentheses, x minus a number. The y1 is the y we figured out way back there. So y minus 4 over pi. The slope of the normal line is that. slope of the normal line is negative pi squared over 8 pi minus 16. That's the slope. Parentheses x minus. The x sub 1 is the number that was given in the question. It was add x equals pi over 4. And we're going to accept this as the answer. That is the line normal to y equals tan x over x, add x equals pi over 4.